Hello, this is the 2020 December mock paper for Year 2 Pure, starting with this question on, first of all, differentiation. So we've got to differentiate this. I would start by writing it out like this. Now it's really important, when I was marking these, lots of people move that 3. That 3 doesn't move anywhere. I would write this as 5 over 3. The x you can move to the top and make it minus 2. But whatever you do, don't bring that 3 up to the top. Okay, so I would write it like this, and then I would differentiate. So dy by dx, 6x squared, and you're going to get plus 10 over 3 x to the minus 3, and then the 7 will just differentiate to give 0. That would be fine for full marks, but you might also want to just put the x cubed back on the denominator, so it looks like that. So that's the answer to part A. For part B, we want to integrate this. So 2x cubed minus 5 over 3 x to the minus 2 plus 7 dx. So this time we want to add 1 to the powers and divide by a new power. So that's going to give us x to the power 4 divided by the 4. This is going to give us x to the minus 1. Remember, we're adding 1 to the minus 2. So that becomes minus 1. Divide by minus 1, and that's going to become plus 5 over 3. And this is going to become plus 7x. You must remember the plus c. I can't remember the mark scheme, but I think you would have lost a mark if you didn't put a plus c there. The question, I think, does say simplest form, so you need to make sure that you simplify this fraction at the front here. So make sure you put a half there. You don't have to do this, but you might just want to put this x back on the denominator and then leave that as it is. So that's the answer to question 1. Question 2, partial fractions question. Start by splitting it up, so you can write 14 plus 6x equals a over the first bracket plus b over the second bracket. And if we multiply everything by this, what we will have is 14 plus 6x equals, and then we'll have a times by everything highlighted, but you'll see that this will cancel with this. So we'll just have a multiplied by 3 plus 2x. And then when we multiply b by everything highlighted, the 3 plus 2x's will cancel. So we'll just have b multiplied by 1 minus x. And now we want to get rid of one of these brackets. So let's get rid of this bracket by making x equal 1. If we let x equal 1, we'll end up with nothing over here. So the left-hand side, if x equals 1, will be 20, and the right-hand side will have 2 times 1 plus 3, so that will give us 5a, and so a is going to equal 4. Now we need to find out what b is. There's lots of ways of doing this. You could make x equal minus 1.5 to get rid of this term here, but I think it's easier to equate the coefficients of x. If it's up to you, you should get the same answers. So if we equate the coefficients of x. So on the left hand side, the only coefficient of x is a 6. On the right hand side, the only things that are going to give you something x are a times 2x, so that will give us a 2a, and the only thing that will give us a coefficient of x over here is b times minus x, so that will give us minus b. So these are the coefficients of x if we were to expand out the right hand side. And since we know that a equals 4 from above, then we've got 2 times 4 minus b. So 8 minus b equals 6, so b has got to equal plus 2. And since the question says write in partial fractions, you should really finish off by writing down your final answer like this. So we've got 2 over 3 plus 2x. Next question, quotient and remainder. Now some students I marked did the quotient rule for this, but it's not asking for the quotient rule. You don't have to differentiate anything. You just want to divide these two polynomials. So we want to divide this by this, and whatever we get on the top will be our quotient, and whatever's left at the bottom, that's our remainder. Now, one mistake that quite a few students made with this question is that since there is no x squared term here, you've got to put a 0x squared or leave a big gap, but I prefer to put a 0x squared. Okay, so then we want to divide all this. So the first thing you do is you do this divided by this, which is x squared, so put that up there, and then you do this times by all of this, which is going to give us x cubed plus 2x squared, and then we want to subtract that. So 0x squared minus 2x squared is minus 2x squared. Now we want to divide this by the x, so that will give us minus 2x. Now we're multiplying this by all of this, so that will give us minus 2x squared minus 4x, and we can bring that minus 2x down. So we've got minus 2x minus minus 4x, so that will give us a plus 2x. Divide that by, so now we're doing this divided by this, so that's going to give us a plus 2. And now we do the plus 2 times by all of this at the front, so we're going to get 2x plus 4 here. Let's bring the 3 down and subtract. 3 minus 4 is going to give us minus 1. And so you really should state in this question what's the quotient and what's the remainder. So this up here is the quotient. So all of this, I'll write it down in a circle. So all of this is the quotient. Whoops. Quotient, and this down here is the remainder. So let's just state that. Okay, so that's the answer to question 3. Next question. Need to do radians for this question. Well, actually in this question you don't have to do radians. I marked some of these papers where students have done all of this in degrees, and that's fine, but the key is when you do the formula for the area of a sector, the area of a sector formula that you do in second year, which is a half r squared theta. That only works if theta is in radians. So if you've been working in degrees for this, then you can't use this formula. You've got to use the formula for the degrees that you would have done at GCSE. So I think it's good to do this all in radians, and then you can use that formula. Okay, so the way I would do this, I would find the angle here. So find angle C first. Now you've got three sides and you're trying to find an angle, so you want to use the cosine rule. So cos C is a squared plus b squared minus c squared over 2ab. 8 squared plus 5 squared minus 7 squared. The important thing is that you remember the thing that goes here has to be the side opposite the angle you're finding, and then you divide that by 2 times 8 times 5. So if you work that out, the right hand side is 0.5, and then you need to do inverse cos of that. Like I was saying, I would make sure you're in radians for this, so I would leave this all in radians, and you get pi over 3 radians for angle C. So now we can find the area of that triangle using a half AB sine C. So area of the triangle is a half AB sine C, which is half times 8 times 5 times sine of pi over 3. So keep your calculator in radians, you should get 10 root 3 for that. So the area of the triangle is 10 root 3. Oops, where am I going? Oh yeah, there it is. Right, so the area of the triangle is 10 root 3. The area, the whole thing is 10 root 3. So that means the area of the sector is 5 root 3. So we want to half this. So the area of that is 5 root 3. Okay, so if the area of the shaded region there is 5 root 3, that has to equal this because it's the area of a sector. So, and we know what theta is. Remember theta, we've worked it out, it's pi over 3. So if I do that down here, we have the area of the sector is a half r squared theta. We know that has to equal 5 root 3 because it's half the triangle. So that's a half times r squared times pi over 3. So what can we do now? Let's simplify the right hand side a bit. If we simplify the right hand side, we've got pi r squared over 6 equals 5 root 3. And we want to get r on its own, so if we rearrange this, we should get r squared is 30 root 3 over pi. So square root that, and you should get 4.07 centimeters. You could write down exactly what it is on to all the places your calculator would allow, but 3 significant figures is usually fine. So that's the answer to 3 significant figures. Next question, number 5. Arithmetic sequence. For arithmetic sequences, I like to write out the terms. So the first term is always a, the second term is a plus d, Next term, always read the question really carefully. This is some scripts I marked had done a geometric sequence here. The third term is a plus 2d, the fourth term is a plus 3d, and so on. Now it's talking about the third term and the ninth term. So this is the third term here, a plus 2d. This is the fourth term, we don't really care about that. And then the ninth term, you can see the ninth term will be a plus 8d. So we know these two terms. The third term is 6 and the ninth term is 30. So we're going to get two simultaneous equations there. A plus 8d equals 30. And a plus 2d equals 6. You could just subtract these two. Subtract. There is an equation, a simultaneous equation solver on your calculator, but in this case, definitely quickest just to do this manually, I think. So you get 6d equals 24, so d equals 4. If d equals 4, then you can put 4 back into one of the equations. Let's put 4 into there, and that will give us a plus 8 equals 6. So a will equal minus 2. So what does the question say? It says find the sum of the first 100 terms. So now you use the sum formula to find the sum of the first 100 terms. Sum formula is this. We find the sum of the first 100 terms. We know that d is 4, a is minus 2, n is going to be 100. There we go. You can just type all that into your calculator, and you should get 19,000. Oh, I don't like putting commas there. Sorry. So leave it like that. So 19,600 is the answer. Question 6. Oh look, I've drawn a circle there. So we want to find the coordinates of the center of the circle and the radius. We want to complete the square for this, complete the square for the x's, complete the square for the y's. So let's write it down. So the x's are next to each other and the y's are next to each other. And I'll put the 14 over the other side. So complete the square for the x's. It's going to give you x plus 3 squared minus 9. Complete the square for the y's. It's going to give you y minus 2 squared minus 4. And move all the constants to the right hand side. And we've got the more helpful form for the equation of a circle is 27. So now we can see straight away there that the center is minus 3, 2, and the radius is the square root of 27, or 3 root 3. Okay, so in part B it says the line with equation y equals k, where k is a constant, is tangent to C. Find the possible values of k. Now the line y equals k is just going to be a horizontal line. So y equals 4 is the horizontal line through 4 on the y-axis, for example. So this is going to be a horizontal line. Horizontal line that is a tangent to the circle. So with these kind of questions, it's always best to do a sketch. So that's why I've done one down here. if we've got a horizontal line that's a tangent to this circle, that's not great. It's supposed to just touch the circle at the top there. It could be there, but it could also be down there. Oh, let's try one more time. Oh, I missed it. Oh, that'll do. All right, so so y equals k could be here, or y equals k could be down here. Now that point there, we already know from the previous part of the question that is minus 3, 2, and we know the radius is root 27 or 3 root 3, so that distance there is 3 root 3. So the equation of this line, well, it's this y value, the center has a y value of 2, and so this height up here, this height is just going to be 2, which would get us to the center, plus 3 root 3. Making a bit of a mess of that, but hopefully you can see that this line here is going to go through the y-axis at the point 2 plus 3 root 3. So the answer to B, one value k can be is 2 plus 3 root 3, but also k could be down here. So if k was down here, then we would have this distance of 2, but then we would have to subtract 3 root 3 because the radius, remember, is 3 root 3, so this is 3 root 3 here. So if you want this k value down here, the value of that k is going to be 2 minus this. Okay, so the other value of k is 2 minus 3 root 3, because we just want the value of k, we want the y-intercept down here. Alright, I should have drawn that circle a bit bigger really, but hopefully you can see, you get the idea from that. What's the last bit? Last bit, it says the line with the equation y equals p, where p is a negative constant, is a chord of C, and the chord is 4 units. So let's see if I can make this a bit bigger this time. Okay, so the chord, it's saying k, it's the line y equals p, p is negative. Okay, so it's going to be a negative line down here somewhere, and it's going to give you a chord on your circle. So we're going to get, let's just draw a triangle here. So this line here is our chord, and the question said the chord has a length of 4. Okay, so if that has a length of 4, remember the circle has a radius of 3 root 3. So what we want to find this distance in this question is that little distance there, because we want to know, this is the equation y equals p. We want to know where this line is going to go through the y-axis, because that will tell us what p is. So as I said, we want to find this small distance here. Okay, so let's see if we can do that by finding the height of this triangle. And it's going to be a right angled triangle. We've split the isosceles into 2 right angled triangles. So now we can use Pythagoras. So h squared is going to equal 3 root 3 squared minus half of the 4, which is 2. And so h would be the square root of 23. Okay, so if h is the square root of 23, That means, if I just try and draw this carefully, remember this is 2 because the center is -3, 2. So that distance there is 2, and we want to find this tiny distance here. Okay, so if h is root 23, then when we do root 23 minus 2, that will give us the distance there. So that distance is going to be root 23 minus 2. And so that will be a positive value because this is going to be bigger than 2. So then when we do that subtraction, we'll get a positive value for this small distance here. But we actually need the y-intercept, which will be negative. So the value of p will be minus whatever you get for this. So I think you have to leave this in surd form. Let's check. Just find the value of p. Always best to leave in surd form though for these kind of questions. So the value of p is 2 minus 23. Let's have a look at question 7. Okay, I think this caused a bit of trouble, although I saw quite a few good answers to this. I think I would start off by changing cosec and cot to 1 over sine and cos theta over sine theta. You've got to decide when you start off one of these questions whether you're going to start with the left hand side and finish with the right, or vice versa. This probably works in both ways, but I'm going to start with the left hand side and end up with the right hand side, hopefully. So I'm going to write down the left hand side, cosec theta minus cot theta squared. Now, whatever you do, don't write down the right hand side here. That's what you're trying to end up with. If you want to write down the right hand side, then feel free to write it down right at the bottom here, because that's where you need to end up. Okay, you don't start off writing what it is you're trying to prove. You start off with one side and end up with the other side. So let's begin here by writing this as 1 over sine theta minus cos theta over sine theta. We've still got to square this. There's probably other ways of doing this, but that's how I would start off, because now we can get a common denominator. We've got 1 minus cos theta over sine theta, and we can now expand well, let's leave it as 1 minus cos theta squared on top for now, because the denominator is going to now be sine squared theta, which we can replace with 1 minus cos squared theta. Okay, and now you might get stuck, or you might decide to expand the brackets on the top. But I think what you should do, if you're not sure what to do next with these kind of questions, is write down the right hand side. So where do we need to end up? We need to end up with this. So how are we going to end up getting to there? Well, if you compare what we've got up here with what we need to end up with, you can see that we don't really need to expand the top bracket because it's already similar to where we need to end up. So the quickest way to do this is to factorize the denominator. So the numerator you can write like this, and then the denominator you can use a difference of 2 squares there. So that would be 1 plus cos theta times by 1 minus cos theta, which is excellent news, because now you know this will cancel with this, and we've ended up with the right hand side now. Okay, as I said, there's lots of ways of doing this question. I reckon that's probably the quickest way of doing it, but you might have done it a different way that still worked. So now the next part of the question, it says, hence solve this. Now, even if you didn't have a clue how to do that part A, you can still solve part B, but because it says hence, it means you have to use the previous answer. So whatever you did for part A, you should now use this equal to this, okay? And then you just need to solve that, okay? So if we put those two highlighted expressions equal to each other, we're going to need to rearrange and solve. So we've got 1 minus cos theta over 1 plus cos theta equals a third. So to solve that, let's multiply the 3 up that side and multiply all this over to the right hand side. Just put brackets around these. So you've got 3 times by 1 minus cos theta equals 1 times by 1 plus cos theta. Obviously we don't really need the 1 there, so we've got 3 minus cos theta equals 1 plus cos theta. Let's get all the cos thetas on one side and the numbers on the other. So we get all the cos thetas on the right hand side. Oh, sorry, I missed out the 3 there. I did that times that, but I forgot to put the 3 there. So let's get all the cos thetas on the right and the numbers on the left. So that will give us 2 equals 4 cos theta. So cos theta will equal 2 over 4, which is a half. And we just need to solve that now between 0 and 360. So do theta equals inverse cos of a half on your calculator. I can't remember if we're in degrees or radians for this. Let's have a look. Okay, in the question it's got degrees, so make sure you calculate it in degrees. So if you do inverse cos of a half, you should get 60 degrees. And I like to use the cast diagram to find the other solutions. We're looking at cos theta equals a half, so that's plus a half. So cos is positive. So where is cos positive? It's positive here and here. So let's draw our 60 degrees in. 60 degrees is here. This would be 90 degrees, 180 degrees, 270 degrees. This is 0 or 360 degrees. And let's find our solution, our other solution. And so where else is cos positive? It's going to be positive down here. So reflect the 60 degrees and start at 0 and work round. And you're going to get that angle there, which will be 360 minus 60. So our other solution is going to be 300. We only want answers between 0 and 360, so we're not interested in any negative solutions. Those are the two final answers to this question.